folks, a question: who's here for this session? Netconf multi-device transactions. Guys, are you here for this?
Looks like one-to-one.
Yeah.
Okay. We solved it. This one also.
Good.
Go ahead.
Well, maybe you can. Maybe why don't we do this? You take the mic and
So,
you tell us how you solved it.
No. So I want to see.
Okay.
What do you have prepared? That's why I asked you to go to slide.
Well, so that's why I'm here for, right? Well, whoever is interested, I'm talking to. But first of all, I want to convey the problem, right? So this is design forum, so we got to design a solution. But the problem, and in terms of the naming, one can. This is the latest one I've come up across with it, which is basically running synchronized transactions across multiple devices, also known as network-wide transactions, configuration transactions. Now, this has something to do with Netconf. By the way, I asked the question in the previous session I did earlier on with respect to Yang, but I'll ask it again because there's a slightly ever-dwindling audience, I have to say. But how many people have played with Netconf mounts on ODL, mounted Netconf devices? Okay, at least a few. So a little bit of a background. Netconf has this concept of configuration data stores, and there is a running configuration, and then there is something called the candidates, which is actually optional, but it's implemented by numerous vendors. And the candidates is kind of instrumental to supporting this network-wide transactions. Now, how is it instrumental? Well, it's instrumental because it allows basically devices to accept configuration, keep it, and then wait for the controller to commit the configuration into action. And this is extremely useful and not possible. This is actually a big feature of Netconf. Not possible using any other mechanisms, CLI and the like, or SNMP previously, because the controller can basically stage the configuration of a particular device. And in this example, I'm saying, we have, let's say, a VPN that needs to be set up between these nodes on site A and site B, and for whatever reason, let's say it also affects the east router. And the controller can basically go and say, okay, Mr. North, here's the configuration. Mr. West, here's the configuration. Mr. East, here's the configuration. And if all those three routers have actually accepted it, then it goes commit, 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 and the configuration is committed on all three. This, of course, solves the nasty problem of having to do the configuration on committed configuration first on device, let's say, North, only for some other subsequent action on another related node like West or East fail, and then having to back out configurations that are incorrect. And this is the bane of NMS solutions and systems in general. The way this is done is, of course, that the validation happens through the candidate's data store, and if the commit doesn't arrive, basically it's dropped, right? So this is basic Netconf behavior. Now, with ODL, we have a Netconf client, Netconf protocol, great. We support Netconf mounts, fantastic. Well, we're using Helium, so yes, we haven't tested Lithium yet, but basically, currently, at least what we've experienced was that, and I did send you the slides for review, but I haven't heard anything. So the way the Netconf, at least mounted API works, is that the configuration is sent to the device only upon when you actually the code executes a commit, or sorry, a submit, or yes, a commit. a transaction commit. So I have some sample code down there. So basically, you begin a transaction, you put some configuration data, and you commit. And there's nothing else in the API that says stage or commit or anything hinting that there is that Netconf capability underneath that should be used. So really, and protocol-wise, the configuration is actually done against the candidate data store. So great, but it's committed immediately. So there's no way chance to roll back. So in a trace example, actually this for some reason should be animated, but in a trace example, that's kind of pseudocode. What it ends up driving is the following configuration, in XML, sent against the candidate's configuration, and then immediately followed, when it's accepted, by a commit from the Open Daylight controller. So there's no way to actually roll it back at that stage. So the ask here is really that since we're using Netconf as a protocol, we are actually doing all of these operations against the candidate data store. It would be great if we could have the API extended to convey these semantics that stages configuration and then commit it at a later date or something similar. So in order to support these multi-device transactions. Now, there are plenty of other errors that can occur with these situations, but I think at least this is a basic feature or API extension that we should consider. And these are all the slides I had. Now it's time for the discussion.
So we consider if applying particular configuration will bring changes to operational state. Imagine you configure a pivot interface or BGP name. So you would like to allocate that device only after operational state has been changed and communicated better.
I guess that's another use case. What I'm describing here is just expose the basic capability of the Netconf protocol.
The validate exposed, so we could invoke validate.
Yes. So.
Okay. Notion, open an improvement factory.
So basically, this type of, here, all of this stuff on the gray is good. The OK is also good. It's been accepted. But then today, this automatically gets sent. It gets immediately committed by. Yes, but there's no other button because commit sends actually, right? So you can either do a send configuration or validate, yes, as you say it, and then a commit followed up by commit. Or register a callback to commit, or a handler to basically gather the response. Yes. So some mechanism like this. I think there needs to be like a check feature or something like this, a callback that can be registered to the validate.
I have the validate background for on the lithium, but not on the helium.
Well, so can you elaborate on the?
So the behavior we changed in the lithium is that the edit RPCs are sent actually as you are sending them. So if you in your code write put, it goes and send the edit config RPC. If you write a comment, write a commit, it's actually comment to send a comment. So the edit config happens before the commit. So we changed that to actually spread the load. So it actually, when you do the put from the code in the lithium, it immediately triggers sending the edit config. We are not waiting for commit as it was in the helium. So that portion you got already there. And given that how the Netconf operates and each Netconf maintains only one candidate store per session, you could be able to send if you compile the RFC6241 YANG model, you could be be able to send the RPC. So you will do the put, send the RPC to validate the config, wait for the response of the RPC, and then invoke the commit on the transaction.
Right, but
let's work around in the Lithium to have that functionality without introducing new API.
send the RPC to validate the config. Okay.
You need to have the logical and entity. So unless you receive all a case, you are not in state to commit.
Yeah.
As long as there's one false, you're at fault.
What happens after if there is an error on any of the puts today in this behavior?
It immediately gets propagated to you as an error, as an exception.
Okay. So it's put.
Or if not, then you will get the commit failed. On the commit, you can listen on the future, and if actually your transaction is invalid, that future, when you hit the commit, you will get the callback that commit failed.
Right. But I think you agree that it would be nicer to have.
Yeah, the validate button.
Yes.
Or the validate callback. In case if it is like. Sure, the problem is with the Netconf is selecting the strategy based on the capabilities exported by device. So that's the harder part of the Netconf, and currently we have this. I believe in the Helium it was implementation only for one support, for one type of capability support, which is candidate. In the Lithium we change with behavior, and we do the selection how the actually implementation behaves based on the capabilities. So, for example, you don't want to send these edit config RPCs during your operations as you are doing them if the implementation is having a write running capability.
Mm-hmm.
Because yeah, you want one point where you send all the configuration at that point. Because if you have a write running, each time you do the edit, it's actually commented also.
But not if you're editing in the candidates data store.
Yeah, but not all devices have candidate data store. There are devices out there which doesn't have.
But here, I mean, at least in Helium, there was no other data store. It was, I wasn't choosing the data store. It was sending everything to candidates.
Yeah, it was sending to the candidate because device supported candidate.
Okay. So you're saying that.
So we are selecting the strategy how the logic of our transaction in the Netconf is implemented based on the capabilities of the device. And I believe there is an SPI which allows you to provide your own strategy.
I mean, I'm wondering whether basically the Netconf API shouldn't be a little bit more, exposed in this sort of selection. Whether this shouldn't be something to the programmer, or you should be doing the smarts behind it.
Some parts of it probably yes, not all the parts. So actually, the Netconf protocol API is only the RPCs, and there is no concept of the transaction. Really. So this is the helper API you are using. You're not using the round of APIs.
No, I'm not saying all of but a bit more of these capabilities.
Makes sense.
Yes. Now, one question on the Lithium behavior that you just explained, and this is just, I guess, for my own understanding. If the Yang model on the target device, for example, features a construct whereby there is, you're configuring one piece of the tree, and there is a reference to another piece of the tree that also needs to be present, and that arrives in a different put. If they are in different puts,
that one is actually, I would say, implementation specific to devices. Usually, the devices actually need the RFC 64.1. I believe for the Netconf actually says that the device must enforce these constraints only on the validate or commit. So it shouldn't be a problem if these are sent via through different tools.
Okay.
If it is a problem, contact your device vendor and point them to bug in their implementation.
Okay, so with puts it should just work.
It should work that way. Actually, the device mustn't enforce you to send all the configuration you want in config. So you could create one subtree, second subtree, and actually the requirement in the Netconf is that the configuration must be valid on the commit, not during the construction.
Mm-hmm. Okay. All right. Good. So I guess outcome is enhancement bug request. Sorry, for a validate button. Thank you. Form, so we got to design a solution, but the problem, and in terms of the naming, one can. This is the latest one I've come across with it, which is basically running synchronized transactions across multiple devices, also known as network-wide transactions, configuration transactions. Now, this has something to do with Netconf. By the way, I asked the question in the previous session I did. Folks, a question: who's here for this session? Netconf multi-device transactions. Guys, are you here for this?
Looks like one-to-one.
Yeah.
Okay, we solved it. This one also.
Good.
Go ahead.
Well, maybe you can. Maybe why don't we do this? You take the mic and
So,
you tell us how you solved it.
No.
And there is a running configuration, and then there is something called the candidates, which is actually optional, but it's implemented by numerous vendors. And the candidates is kind of instrumental to supporting this network-wide transactions. Now, how is it instrumental? Well, it's instrumental because it allows basically devices to accept configuration. Keep earlier on with respect to Yang, but I'll ask it again because there's a slightly ever-dwindling audience, I have to say. But how many people have played with Netconf mounts on ODL? Mounted Netconf devices? Okay, at least a few. So a little bit of a background. Netconf has this concept of configuration data stores.
So I want to see.
Okay.
What do you have prepared? That's why I asked you to go to the side.
So that's why I'm here for, right? Well, whoever is interested, I'm talking to. But first of all, I want to convey the problem, right? So this is designed